In this video, we will use the TI-83 or TI-84 to calculate the standard deviation for the example on the screen. And then we're going to try and find the ages that are a certain number of standard deviations either above or below the mean. So let's get to it. On a minor league baseball team, the ages of each of the players are as follows: 21, 21, 22, 23, 24, and so on. We want to find the mean and standard deviation. Then we want to find the age that is 2 standard deviations above the mean, and separately find the age that is 1.5 standard deviations below the mean. So we'll use our graphing calculator to find the mean and standard deviation. If you have data values in your calculator already, the easiest way to clear them is by pressing up, highlighting L1, pressing clear, and then pressing back down. From here, we're going to enter in all of our data values. Oops, made a mistake. 21, 21, 22, 23, 24, 24, 25, 25, 28, 29, 29, 31, 32, 33, 33, 34, 35, 36, 36, 36, 38, 38, 38, and 40. We should just confirm that we have the correct number of ages listed in here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. Uh-oh, I am missing one. Oh, I am missing a 36, aren't I? 1, 2, 3, 4 36s, and I only have 1, 2, 3 36s entered. So I'm going to add another one at the back. It doesn't matter the order that we type these in as long as we have them all. All right, so now I have 25 players, and I have 25 data values. I know because there's the 26th data value is the first entry that is blank. From here, we're going to press Stat, go over to Calc, press Enter for one of our stats. And again, we only have one variable. It is just the age of the players. And we have no frequency, so we'll leave the frequency list blank. If we happen to have something in here from maybe a prior example, we could just press Delete to clear that. Go down to Calculate and press Enter. And we find that the mean is 30.68, and we have two different standard deviations. We have the sample standard deviation S, and we have the population standard deviation sigma. S is 6.09, and sigma is 5.97. Again, sample, population. So now the question becomes, are we dealing with a sample or are we dealing with a population? Well, we need to go back to the question in order to find out. It says on a minor league baseball team, the ages of each of the players. Since we're talking about each of the players, this would be a population. We're not talking about some of the players or a sample of the players. We're given all of the players' ages. So we are not going to use the sample standard deviation, we will use the population standard deviation. And that it means that our population mean symbol will be mu. So we'll use mu and sigma for this. All right, so we found the mean, we found the standard deviation. The mean again is mu equals 30.68 years old, and sigma is 5.97. So that means that the typical change from the mean for any of these players is about 6 years. From here, we want to find the age that is 2 standard deviations above the mean. Let's do that in a different color though. Let's do that in hot pink. So the age of 2 standard deviations above the mean. To find this value, we'll take the mean and add 2 standard deviations to it. Oops, that's the sample. We want the population standard deviation. So we'll take the population mean, 30.68, and we will add two population standard deviations to it. 2 times 5.97. So we'll come over to our calculator, 30.68 plus 2 times 5.97. I didn't really need to use the parentheses. I was just trying to make it nice and neat. So the age that is 2 standard deviations above the mean is 42.62. And we'll change the color again. Let's go with green for this one. The second thing we want to find is the age that is 1.5 standard deviations below the mean. So to find this age, we will take the population mean and we will subtract 1.5 standard deviations from it. So we'll do the same calculation, 30.68 minus 1.5 times 5.97. So come back over to our calculator, 30.68 minus 1.5 times 5.97, and that will give us an age of 21.725. And that age again is 1.5 standard deviations below the mean.